Hello, everyone. I will be taking you through the data visualization and analysis of my data set. Before I get into this, we hit a snag concerning our data set. We had some kind of errors that we failed to implement, but yes, as I said earlier on, the data set is about it's concerned with image data. It's concerned with image data. So the best way to, of course, visualize image data is through SALI and Synapse. But let's dive into this so that we can get to know what exactly the data visualization techniques are. So first of all, we have heat maps. Now, heat maps work in a way that whenever something, or let's say we have a data type, let's say a column, because these things are usually got from CSV files. So let's say we have a CSV file with a column that has in this case, we are looking at passengers. So we have this kind of key here, whereby the darker it is, the less the number of passengers that we have. And the higher, the lighter. So if we can be able to gauge against what we have here, we see on the y-axis, we have month. On the x-axis, we have year. And this is it's a heat map denoting the number of passengers that boarded some kind of that were on a flight within that time spectrum, a month and a year. So of course, we saw towards the 1990s, we had a lot of passengers who were in flights. So basically, that is just a visualization of the data that we have in our CSV file, and that's the code. And we plot heat maps using Seaborn, as we imported it here, and Matplotlib as well. So the next one, we have correlation matrices. So correlation matrices are just to show the different ways different sets of data correlate together, such that we can be able to visualize what important features of the data we need in order to communicate, in order to make a model that can be able to train based on that. So now here we have things to do with flowers. We have petals. We have something to do with sepals, sepal length, sepal width, petal length, petal width. And so in the diagonal bit, of course, it's going to correlate with itself 1-to-1, because a sepal length has a perfect correlation with sepal length, basically. So that's just a different these are different plots, or the matrix of correlations of how the different features of the data of the data set, how the different features of the data set correlate, basically. And we usually use still Seaborn. Seaborn is actually a way we can be able to visualize data. Also Matplotlib as well. That's why we use these two. And then the next one, we have box plots. Box plots, we implement box plots still using Matplotlib. And here, basically what we do is to take our data and then be able to visualize it in terms of box plots, of course. Here we have we generated random data in form of a normal distribution with 100 as the mean and then 20 as the variance. Of course, now we pass it in here and be able to plot it out using a box plot. And now a box plot has the lower bound, the upper bound, and then the upper and lower quartiles, as well as the median in the middle, which is that orange line. So we can be able to visualize where the majority, or we can be able to visualize the measures of central tendency using the median and all those things, the quartiles and all those things. We also have feature independence plots. Basically, feature independence plots can be made using scatter plots, in that we can be able to show what kind of features have very little correlation or no correlation at all, how one feature doesn't affect the other, or how they're totally independent. So Of course, here we still use Seaborn. Seaborn can help us to plot to make a scatter plot and passing in the parameters x as petal length, y as petal width. So feature independence plots is more of my approach was to use a scatter plot to be able to show the independence of different features. For example, petal width and petal length. In that aspect of flowers. Outlier plots. Basically, outlier plots they of course stem from box plots, but in outlier plots, what we do is to place those data points in our data set that are far away from the basically from the majority of the data. For example, here we have we have we have some we have 20 around 27 and 30 that are outliers. They are far away because most of the data is centered between 10 and 15, around there. 10, let's say 8 to 16, around there. But then 25, 27 and 30 are far away. They're far away. So basically, yeah, that is more of outlier plots to just be able to show what points are far away. And actually, these outliers can affect our model because it affects the bias, it affects the variance of the model. So it helps us to visualize and be able to extract out that data so it does not corrupt or make our model overfit. Basically, something like overfit. Patterns of interest is more of like the opposite of feature independence. Basically, here we can be able to show in a scatter plot how different features correlate. And basically, also the features that interest us that we can be able to use to train our model. Yeah, so that's where we can be able to visualize and see how the different features that we intend to use in our model can be able to help us. And then patterns of space and time. Here we have basing on the example I gave of heat maps, where we had flights and passengers. Here we see how the number of passengers increases as time increases as well. With increase in the years, we see the number of passengers that increase with time. So of course, this can be attributed to maybe the stability of the economy, how passengers are now, how the people are now being able to accommodate flights, how the flight industry is also increasing, and all those things. Yeah, those are patterns of space and time. Now, before I go to exploratory data, earlier on I said that for our data, we can be able to use patterns of stress. We can be able to actually use patterns of stress against time so that we can be able to see how stress actually varies during the day. It usually piles up during the peak of the day, let's say around lunch hours and everything, where people are, getting used to the work, but also, of course, the body needs, you have to succumb to the pressures of the work and all those things. So, of course, stress is bound to increase within the peak of the day and then relax at night. But it depends on the kind of stress. But as for me, I stuck to stress related to work and education. So, and then also for image data, we can use saliency maps. Saliency maps can be able to help us to better understand what pixels or what areas of the image actually contribute heavily to the data, to the model that we are going to train. Now, bridging this to what is here, exploration and cleaning of data. Of course, we have to visualize the data using the different visualization techniques that we have from Seaborn, from Matplotlib. So we have to usually we have to create those plots so that we can be able to understand. So cleaning data is basically removing the unwanted data, basically things that are not useful to us in training the model. You can see in, let's say, of course, in a database, for example, flights or passengers and everything, you might not need to know where exactly the passengers stay or what time they boarded the plane. So that's all useless data when it comes to training the model, because the more the data that we have, then it also takes time. It also increases the time of the model training exponentially. All right. So of course we also have to remove null data because it I don't know, it creates some kind of overfitting of the model, whereby the model wants to take care of all data points and it just distorts everything. Yeah, that is cleaning of data. Of course, now when we have a data set, we have to split it. Some of it is going to be used for training, whereby we are able to train the model through the parameters that it will be established inside, can be able to make predictions. Yeah, that's the training data set where we need to set aside data to train our models. Then the validation is data is the data set aside for fine-tuning the model, because we need to keep on training this model so that we can be able to hit an accuracy level that is acceptable by the people outside who are going to be using it. So the validation data set helps us to tune hyperparameters so that we can be able to gauge and find out what the best model will be. Then the testing data set is used on the best model. Usually it's used in the best model so that we can be able to see and assess the performance of the model that we have chosen. So the validation data set in details is the data set that enables us to tune hyperparameters. So the hyperparameters are basically the parameters that are going to be used to set up the training, to set up the algorithm, or in this case, the neural network. For example, here we have, of course, we have the number. We have the number of layers. We have 3 layers: the hidden layer 1, hidden layer 2, then the output layer. Then within these layers, we also have issues to do with how many features, n features equals, and how many features shall this layer be able to accommodate, all those things, the units for the features, and we also have the learning rate. We have the learning rate here. So hyperparameters, every time we use our validation set, we can be able to change these hyperparameters. For example, let's say learning rate, we can be able to decrement it and also or increment it as well, so that we can be able to achieve the best data. I mean, so that we can be able to achieve the best model. So that's basically it for the validation data set. So yeah, that's it on how these different techniques can be actually applied. That's my understanding. When it comes to the data set, we were not able because we ran into errors. Otherwise, it's doable. When it comes to images, I believe data cleaning or exploration is basically, now, like for our data set, it had different emotions. So we can be able to it has different emotions, so we can be able to classify these emotions in terms of stressed or not stressed, basically. Yeah. I think that's it for today. Thank you for being with me.